In this video, I'm going to show you how to simplify exponent fractions, specifically when you have variables in your exponents. This will cover multiplication and division of fractions with exponents, as well as the addition and subtraction of fractions with exponents. To start off with, here's a mind map to explain the two types. There's multiplication only, when you have a fraction and you only have multiplication within the numerator and the denominator. For these, the steps are slightly different to when you have addition and subtraction within a fraction. For the multiplication type, you have to first prime factorize, and then you have to move everything to your numerator. In other words, you get rid of the fraction. For the second type, addition and subtraction, this is when there are addition or subtraction signs within your sum. So these additions and subtractions don't refer to additions and subtractions within the exponents themselves, but rather within the main part of the sum. And the steps for these types are you have to first prime factorize, then break down everything so that it only has single exponents, and then you have to factorize and simplify from there. But I'll explain that more when I get to one of those examples. Let's first do a multiplication type example. So here we have simplify the following without using a calculator. So this is the same kind of instruction you would see in a test. So let's start. The first step is that we have to prime factorize any numbers that aren't already prime factors. So in this particular sum, 45, 75, 25 and 15 all need to be put into their prime factor bases. So the way you do this is you do a table method. So for 45, and then we start with the lowest prime number, which is 2. Does 2 go into 45? No. Does 3? Yes. 3 goes into 45, and 3 goes into 45 15 times. Then we start again. Does 2 go into 15? No. Does 3? Yes. 3 goes into 15 5 times. 5 is a prime number. It goes into itself once. And that's your table. So the prime factors of 45 are 3 squared, because there's 2 3's, times 5. So we replace that 45 with 3 squared times 5. Then we keep that times 3, and then we have to replace that 75 in much the same way, using the prime factors. You end up getting 3, 25, 5 goes into 25 5 times, 5 goes into itself once. If you have a Casio calculator, you might have a button that says fact, F-A-C-T. That's a factorizing button which will put any number into a product of its prime factors. So if you put 75 equals and then you push the fact button, it will give you this, 3 times 5 squared. So that's what we put in this bracket, 3 times 5 squared, and then we leave the exponent on the outside, 4 minus x. For 25, we can already see it over here. It's 5 squared to the power of negative x times 15. So 15, 3 goes into 15 5 times, 5 goes into itself once. So 3 times 5. So 3 times 5 to the power of x plus 2. Once we have done that, we can now get rid of each of the brackets by multiplying in the exponent into the brackets using the law of exponents. If you remember, the law of exponents states that a to the m all to the power of n is equal to a to the m times n. So we're timesing in that exponent with the exponents in the brackets. Okay, so this equals to 3 to the 2 times the exponent on the outside, and we have to do the same for the 5. 5 times x minus to the power of x minus 3 times 3 times 3 to the 4 minus x times 5 to the 2 times 4 minus x, all over 5 to the negative 2x times 3 to the x plus 2 times 5 to the x plus 2. At this point we have to simplify. So this equals to 3 to the 2x minus 6, we're just multiplying in that 2, times 5 to the x minus 3 times 3 times 3 to the 4 minus x times 5 to the 8 minus 2x. So all we have done is we've removed the brackets from each of the exponents if there was a bracket in order to simplify it. All over 5 to the negative 2x times 3 to the x plus 2 times 5 to the x plus 2. Now I'm just going to reduce this so there's space. Okay, now I have some more space to work. These sums are quite long. Equals to, now what we need to do is we need to group whatever has the same base, we're going to group those exponents together. So if you remember, numbers that have the same base and we times together, we add the exponents. This is the rule, a to the m times a to the n equals to a to the m plus n. So let's start with the 3's. So on the top we have 3 to the 2x minus 6 plus 1 plus 4 minus x times by, now we do the 5's, 5 to the x minus 3 plus 8 minus 2x. We'll do the same thing for the denominator, 3 to the x plus 2 times 5 to the negative 2x plus x plus 2 equals. Now let's neaten this up by simplifying our exponents. 3, 2x minus x is x, 3 to the x, minus 6 plus 1 is minus 5, plus 4 is minus 1, times by 5 x minus 2x is negative x, minus 3 plus 8 is 5, all over 3 to the x plus 2 times 5. Negative 2x plus x will be negative x plus 2 Okay, now we can simplify this even further by using the other rule of exponents, which is a to the power of m over a to the n is equal to a to the m minus n. So what we're doing here is getting rid of this fraction by taking everything to the top, that's at the bottom. So that means that 3 to the x minus 1 in the numerator, we're going to then minus the exponent of the 3 in the denominator. Make sure you put this in a bracket. Minus x plus 2 times by 5 to the negative x plus 5 minus our denominator, minus x plus 2. And now we're going to neaten that up again. So 3 to the x minus x, the x's fall away. It's minus 1 minus 2 times 5 minus x plus x, the x's fall away. We're left with 5 minus 2. So this equals 3 to the negative 3 times 5 cubed. So now we can put this 3 to the power of negative 3 into a denominator. 3 to the power of 3 then becomes 27. And at the top, 5 cubed, 125. And that's your answer. So the steps that you follow is you first put each number into a product of its prime factors. You then multiply the exponents into the brackets with the exponent law. Then you neaten it up and you bring everything that's in the denominator to the top using another law of exponents. am over an equals a to the m minus n. And once you've done that, you neaten it up and you should come to quite a clean looking answer. So that's how you do the multiplication type. Next is simplifying without the use of a calculator. And this time you'll notice that we have a minus sign within our sum. So this means the steps are slightly different. The first step is still the same. Any number that is not a product of prime factors needs to be put as a product of prime factors. 6 is the only number. And if you look, 6, 2 goes into 6, 3 times, and 3 goes into itself once. So the products are 2 times 3 for 6. So that's the first step. 2t plus 4 minus 3 times 2 times 2 to the t plus 1 over 5 to the times 2 to the t plus 2. This next step, because of this divide within the question, likewise if there was a plus, we now have to split each base so that it only has a single exponent. So it can't have a plus in the exponent or a minus. In terms of terms, it can't have two terms. So 2 to the t plus 4 becomes 2 to the t times 2 to the 4. This is kind of like the reverse of the exponent law. A to the m times a to the n equals a to the m plus n. We're doing the reverse. We're going from that right side to the left side. We're breaking it down. Minus 3 times 2 times 2 to the t times 2 to the 1. So we're breaking each individual piece into a single exponent. We do the same for the denominator, 5 times 2 to the t times 2 to the 2. Once we're at this stage, now we factorize. So that's essential for these ones. Whereas in the other type where it's just multiplication, there's no factorizing. So we look, our two terms, that's our one set of terms, or term, and this is our other term. Terms, remember, are separated by plus or minus signs. So for that first term, and then look at your second term and see what is common. So we can see that 2 to the t is common, as well as 2 to the power of 2. If you look at these 2's over here, that would equal to 2 to the 2. So that's the highest common factor. So 2 to the power of 2. So our common factor in both of these is 2 to the t times 2 to the 2. So we open our bracket. To get back to 2t times 2 to the 4, we need another 2 squared. Then don't forget your minus sign. 3, and that's it, because the rest of it is 2 squared as well as 2t, and that's our factor that we took out. All over 5 times 2 to the t times 2 to the 2. What you'll notice now is that we can cancel. Can cancel the 2 to the t with the 2 to the t, and the 2 to the 2 with the 2 to the 2. This is quite common in questions like this, where things start cancelling out, especially the exponents that are variables. So let's simplify this. So now we're left with 4 minus 3 over 5, which is equal to 1 over 5. And that's your answer. So in these questions, whenever you see a plus or minus within the question, your first step is the same as the multiplication ones. You break each number down into a product of its prime factors. The next step is different. Then you have to break up each base so it only has a single exponent, using the reverse of the one exponent law. After you've done that, you factorize. Once you've factorized, things will cancel out, and then you just have to simplify. Let's try one last example. 3 to the x plus 4 minus 6 times 3 to the x plus 1 over 7 times 3 to the x plus 2. Which of the two types do you think this one is? The multiplication type or the addition or subtraction type? I'll give you a moment to think. You should have noticed the minus sign. Therefore, it's the addition or subtraction type. So the goal is to get everything to a prime base with a single exponent. But remember, our first step is to convert any number that's not a product of prime factors into a product of prime factors. So that 6 needs changing. So 3 to the x plus 4 minus 3 times 2 times 3 to the x plus 1 all over 7 times 3 to the x plus 2. The next step is to break everything down into single exponents. Equals to 3 to the x times 3 to the 4 minus 3 times 2 times 3 to the x times 3 to the 1 over 7 times 3 to the x times 3 squared. Now we want to factorize. So what's common to the two factors, to the two terms, in the top fraction? We have a 3 to the x, which is common, and the highest common factor of just 3 would be 3 squared. These two terms here would be 3 squared if we had to put them together, and this on the green highlight is 3 to the 4, so the highest common one is 3 squared. So that's our common factor. To get back to 3x times 3 to the 4, we need a 3 squared minus 2. That's what we're left with, because we already have the 3 to the x and the 3 squared, all over 7 times 3 to the x times 3 squared, which equals to, now we can cancel. 3 to the x cancels, 3 squared cancels, and we're left with 3 squared, which is 9, minus 2 over 7, so we're left with 7 over 7, which equals 1.